So for this one, what's my mu of x bar?
30.
Cool, 30. So then sigma of x bar should be 6 divided by square root of 20. Let's see what that gave me.
1.34.
1.34. All right, so you get 1.34. So for this problem, does the problem tell you anything about the distribution?
No.
No. So anytime they don't tell you anything about the distribution, we're gonna say it's non-normal. So that's gonna be that could be your assumption. If we don't know anything about the distribution, just assume it's not normal. So we already know it's not B. So it's either A or it could be C. So for this one, we have to apply the central limit theorem. So we have to see if n is greater than or equal to 30. So in this case, is n greater than or equal to 30?
No.
No. So since it's not, we know it's not approximately normal, and we'll say the data set is not normal. And that's it for for that one. Any question in regard to the last question?
No.
All right, so up next we're getting into is how to find probability when our n is something other than 1. So for this one, we know mu is equal to 70, we know sigma is equal to 20, we know n is equal to 60, and we know the distribution is normal. So no need for the central limit theorem. So once I know this is a normal distribution, I automatically know we don't need to use the central limit theorem, because the central limit theorem, we only use it if the data set is non-normal or if it's skewed to either side. So let's do part A. So if you look at part A, it says find the probability that x bar is greater than 67. So let's go ahead and draw this. So for this one, the mean should go in the middle. The mean is 70. If you look at it, 67 is to the left of 70. So there goes 67. And lastly, if you look at it, it's greater than means you shade the right side. So I want to go ahead and find this probability. Any questions so far on the way that I shaded it?
No.
Okay. Up next, what we're going to go ahead and do, we're going to find what mu of x bar is, and we're going to find what sigma of x bar is equal to. So mu of x bar is just equal to 70. Sigma of x bar is equal to 20 divided by square root of 16. So what's 20 divided by square root of 16?
5.
5. Everybody good? So far I got mu of x bar is equal to 70 and sigma of x bar is equal to 5.
Yes.
Okay, so now when class calc or your TI-83, if it asks you for the mean and standard deviation, this is what you're going to use for the mean, and this is what we're going to use for the standard deviation. We're not going to use 20 anymore. We're going to use 5 because since we have a sample size bigger than 1, you always have to adjust your standard deviation. So we're going to adjust it that our standard deviation of the sampling distribution is 5. So up next, I'm gonna go over to class calc. All right. So everybody should be able to see class calc. So we're gonna go to stats, distribution, and we're gonna do a normal distribution. So for the normal distribution, we're gonna put the mean, which is 70, and we're gonna put standard deviation. Remember, standard deviation should be 5 now, not 20, because once we adjust the standard deviation, you want to put the adjusted standard deviation of the standard error. And up next, if we want to find the probability, we do CDF. So you press CDF, and now if you look at the lower bound that we shaded was 67. So if you look at it, we get 0.7257. So you go 0.7257. And that's how you find the probability when you have a sample size bigger than 1. So when you have a sample size bigger than 1, you have to adjust the standard error. But if you look at the mean stays the same, the only thing that changes is your standard error. All right, but that's it for part A. Any question in regard to part A?
So you use CDF.
Yeah, you still use CDF. The only thing changing, you're switching your standard deviation.
Okay.
All right, so I'm gonna switch back to my notes. Yeah, I'll do part B with the TI-83. So that's A. So for A, if you look at it, I put the answer right over here. All right, so let's go ahead and now we're gonna do B. So we'll put 70 in the middle. All right. So if you look at this problem, we want to find the probability that X bar is less than 72. So 72 is bigger than 70, so we put it on the right side. So here's 72. So it says less than, it means you shade the left side. All right. So for this one, if you look at the lower bound, what's the lowest value that we have that we shaded to the left-hand side? Like theoretically keep going to which number? Well, theoretically keep going to the left-hand side. So it's going to negative infinity. But if you have a TI-83, you want to put negative 10 to the 10 power.
I thought I was talking, but I was on mute.
Oops. So what's my upper bound? What's the highest value that we have shaded?
72.
Yeah, 72. Cool. And just remember for this one, it's going to ask you for the mean and standard deviation. The mean is still 70, but for standard deviation, you put 5. Okay, so let's go ahead and do it. And this one, I'm going to do it with the TI-83 for that way. You can also know how to do this. So you want to turn on your calculator and you want to hit second and you want to do bars. And you want to select right here where it says normal CDF. So for the lower bound, you put negative 10 to the 10 power. For the upper bound is 72. For my mean will be 70. And lastly, standard deviation is 5. and you press paste, press enter, and you get the answer to be 0.6554. And that's how you do it with the TI-83. If you would have done it with ClassCalc, you should have gotten that same answer. Did anybody do it with ClassCalc get the same answer?
I did.
Good. All right. So that's it for B. Any question in regard to B? All right, cool. Good job, Edgar. All right, so let me switch back to my notes. All right. So what I want you to do, I want you to practice on C and B. So do C, do B, and give me the answer again. Well, the way we got 16 people is the problem tell us is 16 people. It's right here. So they tell us that n is equal to 16. All right, so what I want you to do C and do D.
But every time we find the probability, is that the number for the side that isn't shaded?
What was that again?
Every time we find the probability, is that like how the answer for the other problem was 0.6554? Is that for the non-shaded side?
No, that's for the shaded side.
Oh,
Yeah, like when you find the probability, you find the probability for that shaded side.
Do we put our answers in the group chat?
Yeah, if you want, you can put the answer in the group chat. Cool, super accurate answer. Very cool. Yeah, so everybody seems to have gotten that. So for C, you should have hopefully gotten 0.0808. That is rounding off the fourth digit. And then for part D, you should have gotten 0.0082. All right. Everybody good with these last two parts?
Yes.
All right, so this is kind of like a basic problem. Up next, we should be getting a example of a word problem. For that way, you should be able to get the mean, the standard deviation, and the sample size, and whether or not it's a normal distribution. So, all right. So for this one, says suppose the elevator has a maximum capacity of 16 passenger with a total weight of 2,500. Assume male weight follow a normal distribution with a mean of 182.9 pounds and a standard deviation of 40.8. All right. So for this one, we want to find what the n is. We want to find what mu is. And we also want to find sigma. So for this one, what's my, well, let's do a simple one. What's my mean? You can just type it into the chat.
182.9.
Yeah, 182.9. So we'll put 182.9. What's my standard deviation?
40.8.
0.8 pounds.
Here you go. All right. How many passengers do we have?
16.
16. So that's your n. All right. Everybody good with A, well, n, mu, and sigma? All right. So for this one, asking for this problem, do we need to apply the central limit theorem? So we want to know, should we apply the central limit theorem? So if you kind of go back, we only use the central limit theorem when the data set is non-normal. So for this one, do they tell us the data set is non-normal?
Yeah. No, they say it's normal.
They say normal, so we'll say, no, we don't need to apply the central limit theorem since the distribution is normal. Cool. So if I ever ask you, do we need to apply the central limit theorem? I just want you to kind of go like, okay, if we know the data set is normal, you don't need the central limit theorem. But if the data set is not normal, that's when we need to apply it. All right, but that's it for A. Any question for A?
No.
All right, let's do B. So for B, it says find the probability that one randomly selected male has a weight greater than 156.25 pounds. So for this one, how many male am I randomly selecting?
1.
1. Perfect. Well, actually. So since I'm randomly selecting only one male, for part B, what's my n?
1.
1. Good. All right. And for this one, it doesn't matter since we're only sampling one person, because as long as our data set is normally distributed, we could continue and find this probability. So let's go ahead and find this probability. So we put 182.9. And if you look at 156, so that's to the left, they put 156.25. So which side should I shade? Should I shade the left side or should I shade the right side?
The right.
Yeah, because if you look at it, it says greater than 156, so that means the right. All right, everybody go with this drawing.
Yes.
So up next, we're gonna find what the mu is, what sigma is, what the lower bound is, and lastly, what the upper bound is. So for mu, what's our mu? If you want, you can just type it into the chat. So what is our average?
182.9.
Perfect. For this one, what's my standard deviation?
40.8.
40.8. Notice for this one, there's no need to adjust it because our sample size is 1. Anytime our sample size is 1, whatever the standard deviation they give us, that's the standard deviation you're going to be using. Up next, what's my lower bound? What's the lowest value that I have shaded?
Negative infinity.
So I shaded all the way to negative infinity on this one?
Oh, wait, no.
6.25.
Yeah, 156.25. What's the highest number that I shaded?
Infinity.
Infinity, and if you're using a TI-83, you use T10 to the 10 pound. All right, so let me go ahead and find this probability. So I'll do this one in class calc. I'll do the next one on the TI-83, 84. Oh, here, let me take away all of these. So first you go to stats, then go to distribution, normal distribution. We tell it the mean is 182.9. We tell a standard deviation is 40.8. And since we're finding the probability, we want to do CDF. So we'll do lower bound is 156.25. Upper bound should be infinity. And if you want to show the drawing, you can press that button, it will show it. And if you look at this drawing compared to the drawing that we have, they look pretty similar. So for the answer for this one, we'll put 0.7424. And that's it for part B. Any question for part B?
No.
Okay, let's do part C. So part B, technically what we did, when was that? On Wednesday. Part C is what we're doing today. So for part C, it says, assuming a worst case scenario in which the passengers are all male, what are the chances the elevator is overloaded? Find the probability that a sample of 16 male have a mean weight greater than 156.25 pounds. So for part C, how many male are we randomly selecting?
16.
16. So let's go ahead. Oh, I don't need to draw this again. I need to copy this. All right. So let's go ahead and do this all over again. What's my mean for part C?
180. Oh, wait.
Yeah, 182.9. Perfect. What's my standard deviation for this one? Well, for this one, you need to adjust the standard deviation because now we don't have a sample size of 1, we have a sample size of 16.
It's 10.2.
So now it's 10.2. So that's the difference between part B and part C. Part B is only a sample size of 1. So your standard deviation stays the same. But for part C, since we have a sample size bigger than 1, you do have to adjust your standard deviation. But if you look at the lower bound, it's still 156.25. My upper bound is still infinity, which is 10 to the 10 power. So like the main difference between B and C is that for C, you have to adjust the standard deviation. All right, any question in regard to any of that? Okay, so up next, I'm gonna go to the TI-83. Okay, so for the TI-83, you hit second button, you hit bars, and you do normal CDF. So for my lower bound, what do we say the lower bound is 156.25. If you look at my upper bound, we said is infinity, which is 10 to the 10 power. For mu is 182.9. And one thing about the TI-83, if you want, you can actually just leave it as is. So if I wanted to, I could put 40.8 divided by square root of 16. And it will actually just do the math for you. And then hit paste, hit enter. And that's the answer that you should have gotten with the TI-83 or with ClassCalc. So you get 0.9955. All right. And that's it for C. Any question in regard to how to do C? All right. So let me switch back to my calculator. All right, so this is a typo. This should say part B. This should say part C. All right, so which probability is greater, the probability we found in part B or the probability we found in part C?
Part C.
Yeah. And that's it for part D. Any question for the math problem?
No.
All right, let's scroll on up. Here, let me do something. All right, so for the next problem, what I want you to do, I want you to practice on the next problem. Well, what I want you to do right now, do part A and also do part C. Don't do part B right now. We'll do part B together. But for right now, you do part A and do part C. So take a minute and do those two parts. All right, so let's look at A. So for A, do we need to apply the central limit theorem?
Yes.
Cool. So we'll say yes, since the distribution is right, right skew. All right. Oh, here, give me a minute. For some reason, it's not connected to my. So let me just reconnect that. All right, so but yes, since the distribution is right skew. All right, so let's do C. All right, so for C, what we want to do, we want to find mu of x bar, and we want to find sigma of x bar, and we want to say, is this right, if it's non-normal, so on and so forth. So we want to find mu of x bar, sigma of x bar. We want to say if it's not normal, or if this is approximately normal. So for this one, what would be my mu of x bar?
266.
Yeah, 266. Up next, what we have to do, we have to find sigma of x bar. So for sigma of x bar, what would be sigma of x bar?
16 divided by the square root of 50.
Yeah, 16. So we'll put 16 divided by square root of 50, which is equal to 2.26. Everybody good so far? I got 2.26 for standard error.
Yes.
All right, so now we have to figure out if this is non-normal, normal, or approximately normal. So first we got to figure out if this is normal. Does the problem tell us it is normal?
No.
All right, so it's not normal. So now between non-normal and approximately normal. So to figure out if it's approximately normal, what we have to do, we have to apply the central limit theorem. So we have to see if n is greater than or equal to 30. So is n greater than or equal to 30?
Yes.
Yeah, so since n is greater than or equal to 30, we're going to say this is approximately normal. So, all right, that's it for C. All right. Any question in regard to C?
No.
All right. So let's go back to B. So for B, it says, what is the probability a randomly selected pregnancy lasts more than 260 days? So in this case scenario, how many how many pregnancy are we getting?
50. 1?
Yeah, for part B is actually 1, because it says a randomly selected pregnancy.
Oh, yeah.
So that means n is equal to 1. So if we're saying n is equal to 1, and we know our data set is right skew, can I find the probability of this?
No.
The answer for this one should be no. We can't. So for part B, technically that's your answer. You can't find the probability because n is less than 30. And that will be it for B. Any question for B?
No.
All right, let's do D. So for D, it says, what are the probability that a random sample of 50 pregnancy has a mean pregnancy period lasts more than 260 days? So in this case scenario, how many pregnancies do we have?
50.
In this case, we have 50 because they tell us we have 50. So for this one, can I find the probability?
Yes.
Yes, because we have, well, because n is greater than 30. So the middle will put 266. If you look at this one, we want to find the probability if lasts more than 260 days. So 260 days is here. We want it to last more, so that's this side over here. Everybody good so far with my drawing?
Yes.
Okay, so now what we have to do, we have to find mu, sigma, lower bound, and upper bound. So mu will stay the same as 266. Standard deviation will be 2.26 because n is equal to 50. So you get 2.26. For this one, what will be my lower bound?
260.
260, perfect. What will be my upper bound?
Infinity. Oh, 365.
Oh, no, it should be infinity.
I don't think anyone can be pregnant more than 9 months.
But you have to kind of make it easier for that way you kind of don't have to know any type of information like that. You just always use infinity or negative infinity. For that way you could always get the right answer. Because sometimes if you cut it off a little bit before, it will change your answer a little bit. So yeah, so even though it's unrealistic that somebody could be pregnant for infinite many times, you just always do that because we don't know where to do the cutoff. Does that kind of make sense?
Yes.
All right, good. All right, so I'm gonna go over to ClassCalc and we're gonna find this probability. Oops, ClassCalc. All right, so let me pop that up. So we'll say stats, we'll say distribution, we'll say normal distribution, we'll say mean is equal to 266. We say standard deviation is equal to 2.26. And then we'll say CDF. So the mean will be, well, sorry, the lower bound will be 260. The upper bound will be infinity. And that's your answer, 0.996. So say 0.996. All right. And that's it for that last problem. Any question in regard to how we did this last problem?
No.
So that's how you write that answer. So you kind of have to be careful with the sample size. If they tell you they're sampling more than one, you have to adjust the standard deviation because the bigger the sample size is, the smaller your standard error should be getting. So just be careful with that. All right, so that's gonna be pretty much all for today. So just remember for today, you still have the quiz. The quiz is due at the end of today. So if you still haven't taken the quiz, do take the quiz as soon as possible. For that way you could get those points. Also, if you kind of look at this, if you've been looking at chapter 6 is only 4 pages left. So what we're gonna go over on Wednesday, we're gonna finish those 4 pages, and then if you have any question about anything, but there should be a study guide already available on Canvas. So you should start going over that because you're gonna have your test this weekend. So for the weekend, I'm gonna give you Saturday and Sunday. So you could take it at either one of those days. And once you start the test, you're gonna have 2 hours to do the test.
What?
What?
This weekend? I thought it was gonna be on Monday.
Well, no, because it'll just be easier if I do it at the weekend because hopefully the weekend, like, everybody will.
See, other people also do.
Well, I'll think about it. I'll figure it out by Wednesday.
I work on the weekends. That's why it's annoying.
Okay. I just figure most people will have it free. Okay, well, I'll think about it. And I'll let you know on Wednesday.
But it makes sense why you would have it on the weekend though, so that yeah.
Yeah, like the weekend, like the chances that you work Monday or Saturday and Sunday, or both of those days, are low. So I was kind of hoping to use those probability. But apparently, no. But